Hi guys, hi guys. I'm here to talk about SQL and MySQL. The topic for the week 16, I have chosen my database as MySQL, and MySQL is a SQL type of language database technology, and it is a relational database, relational type of database. So basically there are two types of database: relational and non-relational databases. So when it comes to the scheme of an SQL, that type of database, it is predefined, but whereas in the case of NoSQL, it is dynamic. And when it comes to the query language, it is structured query language, and it is for SQL. And for NoSQL, it is kind of varied by its database. And when it comes to scalability, for SQL it is vertical, and which means that we can improve the RAMs and modifications of the current servers and to improve performances. But in case of NoSQL, it is what we does is like we uh, add more servers rather than improving the adding more features to the current server and to make it performance. So the use cases of the SQL are the structured databases, structured data, complex queries, and transaction management, etc. SQL databases are a good choice for applications that require complex queries and transactions and transaction management, such as e-commerce websites and banking systems. SQL databases are also well suited for storing structured data. The data is consistent and relationship between tables are well defined. And SQL is a good choice when there are complex queries, transaction management, and structured data. Now coming about to the asset properties. The definition of are a set of four key properties that define the reliability and consistency of transactions. A database management system. Acronym ACID stands for atomicity, consistency, isolation, and durability. Atomicity: all operations within a transaction must be either succeed or fail. Like there should not be then there's all if any part of the transaction fails, the entire transaction is rolled back to its original state. Like if any one of the transaction is failed, it should roll back and show the transaction was failed. And consistency: a database is in a consistent state of all the data in the database, and satisfies the constraints that have been defined on the data. Like the data which is in the database should satisfy the constraints that when the data is put, like it should not exceed or be limited, uh, or exceed or precede the data that is being the constraints that has been laid on it. It should be absolutely precise. The isolation: the transactions must be isolated from each other so that they cannot interfere with each other. Like this ensures that each result of each transactions are the same if it was an individual. Like there can be multiple transactions that is going on at the same time, and the same output should be possible when these transactions are executed individually. And when it comes to durability, once a transaction has been committed, its changes must be durable, meaning they must persist even if the system fails. Like even if the system is shut down and then restarted again, the data should be remained. So these are the topics that are the main properties, ACID properties. And when it comes to cap theorem mainly deals with the consistency, availability, and partition tolerance. And when it comes to MySQL, it is when it comes to any database, only two of it is being satisfied. And the in case of MySQL, the available consistency and partition tolerance is being satisfied, but availability is not. Like the every request receives a response, it does not receive the response without guarantee that it contains most recent right. That is not being satisfied by MySQL. So when it comes to normalization is a process of organizing data in a database to minimize redundancy and improve data integrity. It is achieved by dividing the data into smaller, more manageable tables and then defining the relationship between these tables. So there are basically five types of databases. Database normalizations known as normal forms. So the first normal form is 1NF. and all attributes in each table must be atomic, and meaning they cannot be subdivided into smaller parts. Like there is no more division possible. Like one and of states there. So second normal form, and all non-key attributes must be fully functional dependent on the primary key. This means that each non-key attribute must be uniquely identifiable by the primary. So all the non-key, the third normal form, all non-key attributes must be directly dependent on the primary key. This means that no non-key attribute can be dependent on another non-key attribute. Now then comes the boycott normal form, BCNF. All non-prime attributes must be fully functionally dependent on the primary key. And a prime attribute is an attribute that is part of the candidate key, which is minimal set of attributes that can uniquely identify all rows in the table. Fifth normal form, 5NF. All non-key attributes must be directly dependent on the primary key, and there must be no join anomalies. A join anomaly is a problem that occurs when two or more tables are joined together. Okay. There are many benefits like reduced redundancy, improved data integrity, and increased flexibility. And there are also some drawbacks because of this normalization, that is increased complexity and decreased performance. Now we will talk about the constraints in MySQL. Like there are mainly four main types of constraints are used to specify rules for the data that can be entered into a column or table, and they help to ensure that the accuracy and reliability of the data in the database. So there are four main constraints. That is, one of them is not null. The constraint prevents a column from accepting null values. Unique. The constraint that is this constraint prevents the column from containing duplicate values. And primary key, this constraint uniquely identifies each row in a table. Like primary key column must be not null and unique. Like it should not have duplicate values as well as not null values. And the foreign key, this constraint links two tables together by referencing the primary key of one table as a foreign key in the other table. Like there will be two tables and there will be a column that is will be considered as common, will be common with each other, and one will be the primary key in one table, and it will be the foreign key in the other one. That foreign key can be multiple, and can be duplicates. That's one issue with that. So then comes to the relationships in MySQL. Relationships in MySQL are used to connect two or more tables together. This allows you to store data in more efficient and organized way, and to make queries to retrieve data from multiple tables at the same time. So there can be three main types of relationship. One-to-one relationship. In this relationship, one row is in a table is associated with exactly one row in another table. And for example, there will be customer may have one-to-one relationship with an order table where each customer can only have one order at a time. Now then there is a one-to-many relationship. This type of relationship occurs when one row in one table is associated with multiple rows in another table. For example, a customer table may have one-to-many relationship with another table where a customer can have multiple orders. Many-to-many relationship occurs when multiple rows in the table are associated with multiple rows and another table. For example, an order table may have many-to-many relationship with a product table. Their order can contain multiple types of products, and a product include multiple, and these products can include multiple orders. These are the relationships, and these relationships are created using foreign keys. A foreign key is a column in the table. We have already talked about that. Now we will talk about the joins. Joins in MySQL are used to combine data from two or more tables. This allows one to retrieve data and spread across multiple tables in a single query. So the four main types of joins are inner join, the type of join that returns all rows from both the tables where the join condition is satisfied. Left join, this type returns all rows from the left table and the matched rows from the right table. And right join, this join returns all rows from the right table and the matched rows from left table. Full outer join, this type of join returns all rows from both tables regardless of whether they match the condition. They match the join condition. Joins are specified to select statements using join clause, and join clause specifies the tables that you want to join and the join condition. So moving on, three schema architecture. The three schema architecture in MySQL is a logical model of for organizing databases. Database schemas into three separate levels. Conceptual schema. This is the highest level and represents the user's view of the data. It describes the entities and relationships between entities in the database without regard for how the data is physically stored. That is conceptual. Logical Logical schema. This level describes the data in a more detailed way, including the data types of the and constraints for each attribute. It also describes the relationship between tables. Physical schema. This is the lowest level and describes how the data is physically stored on disk, including the file format, indexes, and other storage details. The three-schema architecture provides a number of benefits, including data abstraction. The three-schema architecture separates the user's view of the data from the physical implementation. This allows the physical schema to be changed without affecting the user's view of the data. Data independence. The three-schema architecture also provides data independence, which means the changes to the logical schema that can be made without affecting the physical schema. Flexibility. Three schema architecture is flexible because and can be used to support a wide variety of database applications. MySQL implements the three schema architecture to a number of features, including DDL, DHML, and DCL statements. We will see about that in the further. Indexing in MySQL. Indexing is a technique for improving performance and of database queries by creating a structure that allows MySQL for to quickly locate specific rows in a table. And indexes can be created on one or more columns in a table, and they can be used to speed up both select and order by queries. MySQL uses a variety of indexing types, including B types, B trees, hash indexes, and spatial indexes. The type of indexing that MySQL uses depends on the data type, that on the data type of the columns being indexed, and the type of queries that will be performed on the text. To create index, you use the create index statement, and create index statement specifies the name of the index, tables to be indexed, and the columns to be indexed. So moving on, we'll see using the aggregate functions. Aggregate functions in MySQL are used to perform calculations on groups of data and to return a single value. They are often used to summarize data, such as calculating the average, sum, or count of values in a column. So average calculates the AVG calculates the average of the core values of a column, and counts the number. Maximum returns the maximum value in a column. Minimum returns the minimum value in a column. Sum calculates the sum of the total values in a column. So these are the aggregate functions. Now when coming to the scalar functions in MySQL are functions that return single value. They can be used to perform a variety of operations on data, such as converting data types, formatting data, and performing calculations. Some of the most common scalar functions in MySQL include concat. Concatenates two or more strings. Each formats a date value according to specified format. Length returns the length of a string. Bit returns a substring of a string. Now returns the current date and time. Rounds a number to a specified number of decimal places. Scalar functions can be used in select statements, where clauses and other SQL statements, for example, for its users for to retrieve data. Now coming to MySQL queries. MySQL queries are used to retrieve, manipulate, and manage data in MySQL. They are written in data in the SQL and programming language, which is a standard language for interacting with databases. And there are main Four main types of MySQL queries. Select statement are used to delete data from a MySQL database so that we can see the data. Insert is used for inserting values into new data into a MySQL database. And update statements are used to update the existing data in MySQL statements. Delete statements are used to delete data from MySQL statements. And yes, there are many examples with that, and I have practiced it. And when it comes to foreign key and primary key, yes, foreign key in MySQL is a column in one table that references the primary key of another table. This helps to ensure the integrity of data in the database by preventing orphaned rows from being created. The primary column or set of columns is in a table is uniquely identified, and primary keys cannot be not null, cannot accept null values, as well as they cannot accept null values, as well as uh, they cannot be duplicate values in their code. And that's closure table in MySQL is a special type of table that is used to represent hierarchical data in a relational database. It consists of two tables, one for the entities in hierarchy and one for the relationship between those entities. The closure table is used to store all of the possible relationship between entities in the hierarchy. It includes the direct relationship between entities as well as the indirect relationships that are inferred from direct relationships. For example, if you have a hierarchy of users, the closure table will store the following relationships. User A is a patient or parent of user B, user B is a parent of user C, user C is a child of user C. The table can be answered to various questions. Now we're coming to group by. Group by clause is used to group rows in a table to perform aggregate operations. Group by clause in conjunction with aggregate functions such as count, sum, average, maximum, and minimum. These functions allow you to perform calculations. Having clause is used to filter groups of rows returned by group by clause. Yes, when group by is used, it is similar to the where clause, but it is only applied after the group rows have been grouped. Yes, when having is replaces where clause, and when we use group by. Transactions in MySQL. Transaction in MySQL is a group of SQL statements that are executed as a single unit. This means that either of all the statements in the transactions are successful, or all of them are rolled back. Transactions are used to ensure integrity of data in a database by preventing partial updates and other errors. DML data manipulation language in MySQL is a set of SQL statements that are used to manipulate data in database, like insert, update, delete, insert. These are data manipulations. Manipulates the data, deletes the data, updates the data, inserts the data, updates them, and DDL data definition language. These are accessible statements that are used to define the structure of database, including tables, indexes, and views, like create, alter, drop. These are basically the defining the data. Like you are creating a table, you are altering the table, you are dropping the table, you are creating a view, you are altering a view, dropping a view. These are basically creating, adding a new column, dropping a database. DCL is a control system. You control the access to the data, like grant, revoke, deny, and grants permissions to the grants permissions to users and group of users. Revokes permissions and from users. Denies permission. They don't need to ask for it. It can also be used to create complex permission schemes, and such as role-based access and unprompted allows one to have these. So these are the main topics that I had covered. And thank you.